Okay, so now we're going to look at cost estimation using linear regression. When you hear the word linear regression, this just means you're making the equation of a line, all right? Yes. So we're going to be forming a cost function again. That's going to help us predict the cost that will incur if we do a certain level of activity. Okay, this cost function it just helps you predict or estimate the costs that you incur for a certain level of activity. Right? Yes. So if you remember, our the total cost equals fixed cost plus variable costs. All right. Now in linear regression, this becomes y equals a plus bx. Y is the total cost, fixed costs are a, b is the variable costs. Okay, so we've got this information here. It says electricity costs for the first 6 months of the year are as follows. You've been given the months, the production in terms of units, and the costs. Okay, so what you need to do once you see this, you need to know, okay, what is my x variable? Okay, x is going to be the production or the units. All right, your y variable will be the cost. Okay, so production is the x variable, y is your costs. So we're going to make a table. So I'm going to use Excel here. Okay. Months. Okay, then we've got production, which is our x variable. And we've got our costs, our y variable. Okay, so the months we've got Jan, February for 6 months. So March, April, May, June. Right. Then the costs for the production. Production in units, 340 units in January, 300 units in March, 380 units. No, 308 units is in March. February is 300 units. April, 420 units. May, 400 units. June, 360 units. Okay. Then next we've got our costs. Let me just put them down to 1,260. 1,160. Okay. So the linear regression table. Okay. Your first column that you need to add in is you're going to multiply your x variable and your y variable. Okay. So this xy column I've put here. I'm just multiplying the production in units and the costs. Okay. Then the next column, the units, you're going to square them. Okay. X squared here. Okay. So this is how you do it. First things first, you're going to multiply your x and your y variable. 340 times 2,260, you get that. 300 multiplied by 2160. Get that. 380 multiplied by uh-huh. It's for you to choose. No, it's y variable is the cost. Okay, y variable is the cost. Okay. Then x variable is the production in units. Okay. Just take this as a rule of thumb. When they give you a table in a question, they won't tell you that your y is this and your x is this. So just know your y is your is always going to be the cost. Then your x is the activity level, which can be production in units, labor hours, machine hours. Okay? I hope we've got that point down so that you do not mix the two. Okay? Your y variable will always be the costs. Is that okay, Mr. Ronald? Okay. So that's the first column. Just multiply x times y. Then the second column here, our thing, our production, we're squaring it. Okay. So 340 squared, 100. What number is this? 115,600. Okay. 300 squared, 90,000. 380 squared, 144,400. 420 squared, get that number. 400 squared, you get that number. Okay. 306 squared. Sir, could you kindly mute your mic? 360 squared, you get 129,600. Thought I heard someone wanted to log in. Yes. Okay, colleagues, that's what you do. First multiply x times y, then your x variable square it. Okay. Then after you've done all of that, get your totals. Okay. Get all your totals. Your totals for x, add all of them up. 340 plus 300 plus 380 plus 420 plus 400 plus 360. You get your total. Okay. Always get totals also. Okay. Even for our costs, we add up all these figures here. Okay. Even for x multiplied by y, we add up all these figures here. Okay. Even for our x squared, we're going to add up all these figures here. Okay. So that we can now put them in the formulae. Okay. These formulae, I think they're given to you in the exam. Okay. These ones here to be specific. These ones. Find your variable cost and find your fixed cost. Okay. So we're going to use these formulae here. So let me just bring the table back to Word. All right. So we'll find first our variable costs. B represents the variable costs, okay? N, this small letter n is just number of data points. Okay, so we've got 6 months. Okay, so n equals 6. Okay, you've got 6 months, or you can count here. 1, 2, 3, 4, 5, 6. Okay, that is your n, number of data points. Right? So we can now substitute into this formula here for our variable cost. Where is the draw option? Okay. So we're going to say B for variable costs. Okay, so I'm following the formula there. The formula will be given to you. Uh-huh. Yeah, it will be always provided. It will be always provided. So n is 6, so you're going to say 6 times this E here, sigma, summation of x and y, is just saying the total of x, the product of x and y, which is in our table here. You come to the x and y column here. The total was what? This number here. 5,041,760. Okay. All these figures, I'm getting them from the table. So we say 6 times. Someone with a calculator so that we don't waste time with these calculations. Okay. First, you start with 6 times 5,041,760 minus sigma E, the total of X, okay, which was just basically the total of the production units. Here's X, the production units. The total is 2,200. Multiplied by the total of Y, okay, which is thing 13,706. Okay, let me just put it like this so that even for your studying purposes, you will be okay. Okay, this is sigma X here. And this is sigma Y here. And this is sigma XY. And this one next is sigma X squared. Okay, yes. So yes, sigma X, that was thing 2,200 multiplied by 13,706 over n. N is 6 multiplied by sigma X squared, which is this one here, 816,000. over, minus sigma x squared. Now take note, pay attention here. This is sigma x squared. So this number here, this 2200, we are squaring it. Don't put this 816,000 again. No. Okay. It's this 2200 which we are squaring. Okay. So now we can do our simplifications. Yes. Has anyone done 6 times 5,460,000? Or 5 million, 6 times 5,417,760. Okay, you get this number here. Just use Excel here. Get this number here. Yay. 30,250,560. 30,250,560. Right. Then this one 2,200 multiplied by 30,706. 30,153,200. 30,153,200. Okay. Then here below, we're going to say 6 times 816,000. 4,896,000. 4,896,000. And then 2,200 squared. That's wonderful stuff. 4,840,000. 4,840,000. Okay. All right. We'll just hold on, sir. Okay. Let me do it step by step for our other colleagues. All right. But I'm happy I found it. Okay. So we're going to do 30,250,560 minus 30,153,200, 97,360. 97,360. Okay, then below here we have 4,896,000. So in the exam, colleagues, these questions they take time, 56,000. So it is very paramount that you do not make a mistake and you don't take a lot of time on it. So 56,000 here. Then 97,360. 97,360 divided by 56,000. 1.73. 73. Yes, that's correct, sir. Wonderful. Okay. No, you don't need to go that far. Just two decimal, yes, two decimal places. No need to have a lot of decimal places. Okay. Okay. Yes, sir. 1.74, 1.73, whichever. Okay. Since there was an 8. Okay, yeah, there was an 8 there. So put 1.74. All right. Our fixed costs. Okay. Which is A. Summation of Y was what again? 13,706. 13,706. Our N is 6. Okay, then here our B, which is 1.74. So you always calculate B first, okay? Multiplied by summation of X, which is 2,200. Okay, over 6. Okay, so 13,706 divided by 6. As I'm putting my phone on the charger. Mr. Ronald, 13,706 divided by 6. Okay. 2,200. Okay. Okay, maybe two decimal places. Then this one, 1.74 times 2,200 divided by 6. I'm getting 638. Okay. So 2,284.33 minus 638. We get 1,646.33. Okay. So our total cost function is going to be like this. Remember, y is the total cost. A plus bx. Our A is 1,646.33 minus 1.74x. Okay. So this is our cost function here. All right. And we can now use it to estimate, because remember in this question it says estimate the total cost when 500 units are produced. Okay, so if 500 units are produced, we're just going to substitute X for 500 units. So 1.74 times 500, we get, Mr. Ronald, help me here. 1.74 times 500, as I'm typing here. 870. Okay. So we're going to say 1,646.33 minus 870. You get 776.33. 776.33. Okay, colleagues. Yes, that's how we do cost estimation using linear regression.